All right, team, here with a quick video on skeletal structures. Here are my hand-drawn versions of skeletal structures, and how to view these. What are we looking at when we're looking at these things? I will let you know, you do not have to draw a skeletal structure by hand. I will not give you a formula, like I would not give you like C6H12O6. I would not give you a formula and expect you to turn that formula into a skeletal structure. But when we're looking at these, I would be able to expect you to determine the number and types of atoms that are in a model like this, because that's going to be important for when we're thinking about if a molecule is hydrophobic or hydrophilic, right? If it can mix with water or not. So when we're looking at these, what we are looking at, these are a shorthand way of drawing out really large and kind of repetitive organic molecules. And the rule that I like to use for these is ends and bends. And what I mean by that is that everywhere there's a dead end, like right here, there's a dead end right here, or a bend, as long as there's nothing else written there, we can assume it's going to be a carbon and as many hydrogens are necessary to fill in all of those bonds. All right, so what do I mean by that? So let's look at this one up here. So each dead end, oops, sorry, I got out of focus. Okay, each dead end and each bend, as long as it's not explicitly written that it's a different atom, it's going to be a carbon. So here's a carbon, here's a carbon, carbon, carbon. This is a bend. There's still a carbon here. And then this is a bend as well. So there's a carbon here too, okay? And then there's a carbon here as well. Okay, so, sorry, got a little messy. That's a carbon. So we have 1, 2, 3, 4, 5, 6, 7 carbons in this molecule. So each dead end and bend is a carbon, right? This right here isn't a carbon, it's an oxygen. Okay, so if it's anything besides basically carbon and hydrogen, we write it out directly. Okay, so that's an oxygen atom that's bonded right there to a carbon. So if we remember though, carbon needs 4 bonds. Okay, so each carbon has to have 4 bonds in order to be stable. So let's look at, for example, this carbon right here. We have 1 bond shown right here, another bond shown right here. So this carbon only has 2 bonds that are shown. So we can assume that it has 2 hydrogens like that to fill in its 4 bonds, right? Same thing with this one right here. So this one carbon has 1 bond shown here, another bond shown here. So it only has 2 bonds that are shown, so we can assume it's bonded to hydrogens to fill in its 4 bonds. This carbon, 1, 2, and it has 1, 2 bonds to this oxygen. So it has 1, 2, 3, 4 bonds already, so it doesn't have any hydrogens coming off of it. This carbon right here, this bend, has 1 bond shown to that oxygen and 1 bond shown to that carbon. So it only has 2, so it's going to have 2 hydrogens coming off of it. I wrote this up and down just for space. I wrote them on either side of here just because of space. You can do whatever makes the most sense for you. For us in our class, if you take OChem, they'll be more specific. Okay, there's a carbon here. So it has 2 hydrogens coming off of it. And then this carbon at the end has only 1 bond shown, so it's going to have 1, 2, 3 hydrogens coming off of it. Okay. Okay, so again, ends and bends are carbons, and then as many hydrogens are necessary to fill in those 4 bonds that carbon needs. And this includes being in a ring structure like this. So each bend is still a carbon, even when it's in a ring. My ring is a little bit uneven, but that's fine. So each bend, like that's a carbon right there. That's a carbon right there. Another carbon right here. Another carbon right there. Carbon right there. Carbon right there. So we have 1, 2, 3, 4, 5, 6, and then 7. So 1, 2, 3, 4, 5, 6, 7 total carbons in this molecule. So each of these purple dots is a carbon. And then remember, we need as many hydrogens as necessary to fill in that 4 total bonds. So let's start with this one right here. So this carbon right here has 1 bond to this OH right here, 2, a second bond to this carbon right here, it has a third bond to that carbon right there, so it has a hydrogen right here. Okay, same thing, let's do for this carbon, 1 to this OH, 2, 3, so it only has 1 hydrogen. This carbon right here doesn't have any OHs, so we'll put 2 hydrogens coming off of it. Okay, this carbon has 1, 2, 3 bonds shown, so we have 1 hydrogen. This carbon has 1, 2, 3 bonds shown, so it has 1 hydrogen. This carbon has 1, 2, 3 bonds shown, so it also has just 1 hydrogen. Okay. So it's gonna, any atom that's not a carbon or hydrogen, like this oxygen right here, or this one right here, those will be drawn out. And then the rest of the ends and bends, the rest of the, like this right here, end and bend, each of these would be a carbon with as many hydrogens necessary to complete carbon's 4 bonds.